this is a really interesting statement right here. The remainder of a polynomial division actually means three different things. First of all, we've just discovered that by the division algorithm and by the remainder theorem that p of x is divided by x minus c, we find that the remainder is actually equal to p of c. That is, it's the same as evaluating the function at x equals c. The p of c is equal to 0 if and only if x minus c is a factor of p of x, and the remainder is 0 if and only if c is a 0 of p of x. So saying things like a polynomial has a factor of x minus c is equivalent to stating c is a 0 of p of x, and not only that, but we would find that the coordinate c0 is an x-intercept of the graph of our polynomial p of x. So this synthetic division trick is really cool because it gives us all kinds of ways of finding 0, factor, and or x-intercepts of a graph of p of x. So let's check this out. Let's verify that x minus 2 is a factor of p of x. In this case, p of x is 3x cubed minus 2x squared plus 9x minus 34. And write p of x as the product of x minus 2 and the reduced polynomial q of x. Well, if we're interested in finding out whether or not it's a factor, we go through our polynomial division and check out the remainder. So we're going to put 2 on the outside of our division bar. We're going to put our coefficients of p of x, which are 3x cubed. We don't need the x right there, right? Remember, synthetic division, we're just dealing with the coefficients. Negative 2, positive 9, and negative 34 as our coefficients. If we carry down our leading coefficient of 3, multiply it by 2, add down the column, multiply that by 2, 8, add down the column, 17. 2 times 17 is positive 34, and our remainder is 0. So what does this mean to us? Well, what we've just done is we've taken a third-degree polynomial, divided it by a first-degree factor that's going to give us a second-degree polynomial. In other words, every time we do synthetic division, the remainder, the reduced polynomial, which we call our quotient, q of x, always has a degree of 1 less than the dividend, which is that polynomial p of x. Right? So what we will say then is that p of x is equal to the product of our factor x minus 2 times the reduced polynomial of 3x squared plus 4x plus 17. And so when we're asked to write the p of x as a product of x minus 2 and the reduced polynomial q of x, that's what we're really looking for. If we were to carry out this multiplication, we would find that p of x is indeed this product. And that's all we're looking for in this section. So, good luck with your homework. See you in class.